Today we are going to talk about absolute value equations and inequalities. Absolute value is a number's distance from zero, so the absolute value is denoted with straight up and down bars around a number. So if we're talking about the absolute value of 7, we're talking about the number's distance from 0. So 7, the absolute value of 7 is 7. But also, the absolute value of negative 7 is also 7. Okay, when we're talking about the number's distance from 0, you'll need to remember that there is no negative distance. Distance must always be a positive number. So when we're taking the absolute value of a number, it will always come out positive. Okay, a number's distance from 0 must also always be positive. So here is an example using a graph. If we have the absolute value of 7 and we have a number line, let's put a point at 7, and we also have the absolute value of negative 7, we'll put a point at negative 7. If we are going to count its distance from 0, from 7 to 0 is 7 units, and also from negative 7 to 0 is also 7 units. Okay, just a quick graphical example of how your absolute value always has to be positive because it is a distance. Now let's look at solving an absolute value equation. Okay, when we look at the equation, we have the absolute value of x minus 5 equals 7. We must do two equations from that. The first one will be just exactly like it says. X minus 5 equals 7. The other equation that we need to set up is that x minus 5 can also equal negative 7, because with the absolute value of that negative 7 will also be 7. Okay, now we're just going to solve it like a regular equation. So to solve x minus 5 equals 7, we would add 5 to the left, so we add 5 to the right. So we get that x can equal 12. Okay, if we solve the second equation, x minus 5 equals negative 7. Okay, again, to solve this, we would add 5 to the left side, so we add 5 to the right side. And we get that x equals negative 2. Now let's see how this works. Let's substitute these numbers back in for x. If we take that x is 12 and we substitute 12 back in for x, we would say that 12 minus 5, the absolute value of 12 minus 5, equals 7. Yes, 12 minus 5 equals 7, so that's all good. If we were to take the negative 2 that we solved for and substitute it in for the x, we would have the absolute value of negative 2 minus 5 also equals 7. Well, negative 2 minus 5 is negative 7, and the absolute value of negative 7 is also 7, so it's all good. So you must do two equations anytime that you have an absolute value equation. Let's take a look at another example. We have an absolute value equation, 5x minus 10. The absolute value of 5x minus 10 equals 45. So our first equation is just like it sits. 5x minus 10 equals 45. The second equation is going to be 5x minus 10. Now it's going to equal negative 45. You must also set it equal to the negative number. Now we'll solve this. We'll add 10 to the left side and add 10 to the right. And we'll have 5x equals 55. Divide both sides by 5 and we get that x equals 11. Okay. The second equation, 5x minus 10 equals negative 45. We'll add 10 to the left, so we will add 10 to the right. So we have 5x equals negative 35. We'll divide both sides by 5, and we're going to get that x equals negative 7. Now we're going to substitute our solutions in for x and see if it makes a true statement. If we have the absolute value of 5 times 11 minus 10, does that equal 45? Well, the absolute value of 5 times 11, 55, minus 10, 55 minus 10 is 45. So the absolute value of 45 does equal 45. So we're good. Now we're going to substitute negative 7 in. The absolute value of 5 times negative 7 minus 10 needs to equal 45. So 5 times negative 7 is negative 35 minus 10 equals 45. So that's the absolute value of negative 45 equals 45. And that is true, because the absolute value of a number is its distance from 0, and negative 45 is 45 units from 0, so we're good. The absolute value inequality is just a little bit different. it is similar in that you still have to write two problems. So the first problem is going to be just like it says, 4x plus 5 is greater than 13. The second problem, the first part is going to be the same, 4x plus 5, but now we must change the symbol and make the 13 a negative 13. So you change the inequality symbol and you make the right side negative, the opposite of what it is. So now we are going to solve this. So we're going to subtract 5 from the left. So we subtract it from the right. Have 4x is greater than 13 minus 5 is 8. Now we're going to divide by 4 and we're going to get that x is greater than 2. Now we're going to do the second inequality that we needed to set up. Again, to set up the second one, you change the direction of the symbol and you put the opposite of what they have on the right side. You change the sign on it. So we're going to subtract 5 from both sides of the inequality. So that is going to give us that 4x is less than negative 18. Now we are going to divide by 4, and we're going to get that x is less than negative 18 fourths, which is negative 9 over 2. Okay, if we were going to put that on a number line, we are looking for the numbers that we have here. Put them in order on your number line. Negative 9 over 2 is negative 4.5, and it says it is less than that. So it's an open dot going to the left. Now the other number we're looking for is 2. Okay, x is greater than 2. So we're going to put an open dot and it's going to go to the right. What this tells us is that we can put in any number that is greater than 2 and it will make a true statement, or any number that's less than negative 9 halves, negative 4.5 will work also. Let's take a look at one more inequality. Okay, if we set this up, it's going to be just like it says, x plus 4 is greater than or equal to 6, and then we will have x plus 4, change the inequality symbol direction, less than or equal to negative 6. Okay, so on the first inequality you set up, we're just going to solve it. Subtract 4 from both sides, and we will have x is greater than or equal to 2. Okay, on the second inequality you set up, we're going to have to subtract 4 from both sides, so we will have x is less than or equal to negative 6 minus 4 is negative 10. So if we graph that, again, we are looking to put the numbers on the number line in order. So negative 10 is on the left and 2 would be on the right. Okay, x is greater than or equal to 2, so I'm looking for a filled-in circle on 2, and it's greater than, so it's going to the right. X is less than or equal to negative 10, so we have a filled-in dot going less than, so it goes to the left. The last thing that we are going to look at in this lesson is checking for extraneous solutions. So here we have a problem. It's an absolute value equation. So remember, we must write two equations. 2x plus 12 equals 4x, and then we will have 2x plus 12 equals negative 4x. Okay, so we're going to solve this. We're going to subtract 2x from the left, and we'll subtract 2x from the right. Okay, that will go away, and we will have 12 equals 2x. Now when we divide both sides by 2, we will get x equals 6, so that's great. Okay, now we are going to do the second equation. We'll subtract 2x from the left, so we'll subtract 2x from the right. So we get that 12 equals negative 6x. Now we're going to divide by negative 6, and we're going to get that x equals negative 2. All right, we got two solutions, but we have to check to make sure that they work. So now we're going to substitute them into the equation. Okay, so if we have the absolute value of 2 times 6 plus 12, does that equal 4 times 6? So all I did was rewrite the equation, and we substituted 6 in there. 2 times 6 is 12. 12 plus 12 is 24. The absolute value of 24 equals 4 times 6 is 24. That's true. So therefore, 6 is a true solution. That works. Now we're going to substitute negative 2 in our other solution. So we have the absolute value of 2 times negative 2 plus 12. Does that equal 4 times negative 2? Okay, 2 times negative 2 is negative 4, plus 12 is 8. So we have the absolute value of 8 equals 4 times negative 2 is negative 8. Okay, the absolute value of 8 is 8. Is this true? Does 8 equal negative 8? No, it does not. Therefore, even though we got this solution right here of negative 2 equals x, when you plug it back in, it does not make a true statement. Therefore, this is an extraneous solution. And cannot be used. So it's very important to always check your solutions when you are doing your absolute value to make sure that it's making a true statement. So the only true solution we could use would be that x equals 6. We could not use the x equals negative 2.